Dear students, today we will be doing the topic reciprocal lattice vectors in terms of direct lattice vector. In the previous video, I have told you what is a reciprocal lattice. This is basically the collection of points from which the diffraction actually occurs. Those set of points tells us the diffraction pattern of a specific crystal. And how we draw it, we had three steps. First of all, we have to consider one point. Then we have drawn all the set of planes in that lattice, and that from that specific selected point we have drawn perpendicular to all the set of planes, and at the end of the perpendiculars on the length equals to 2 pi divided by d, where d was the interplanar distance, we marked a point, and collection of such points gave us a reciprocal lattice. Now in this video we are going to find the relationship between A, B and C. What are A, B and C? These are my direct lattice vector, what we call as primitive lattice vector. ट्रांसलेशन के लिए जो हमें हेल्प करते हैं. And now because अभी हम direct lattice में नहीं रहे, now we have shifted to the reciprocal lattice, and now I want to define new set of vectors that I am denoting by A star, B star, C star. Notation can be different in different books. In some books they have taken A1, A2, A3 in direct lattice and B1, B2, B3 in reciprocal lattice. So that is your own choice. These are reciprocal lattice vectors. So one thing I want to again draw, we have considered some set of planes and from here we have drawn the perpendicular on this green plane and this pink plane. So if we take x, y, z like this is x-axis, this is y-axis. So if we consider this perpendicular, it is normal to the plane in which direction? Let me draw it like this. So this is my normal and the plane is along y and z axis. So x axis perpendicular, the perpendicular along the x axis is normal to perpendicular to what? Y and z plane. कौन सा परपेंडिकुलर है y और z प्लेन में? जो हमारे x एक्सिस वाला वेक्टर है. तो x एक्सिस वाले वेक्टर को हम a स्टार बोल रहे हैं. सिमिलरली जो हमारा b स्टार वाला वेक्टर होगा, दैट मीन्स जो y एक्सिस के अलोंग है, वो किस प्लेन के परपेंडिकुलर है? वो इस प्लेन के परपेंडिकुलर है. And this plane is along x and z. I hope you have got my point that the perpendicular to x, z and x plane वो है हमारा b vector, and similarly we have c vector which is perpendicular to x and y plane. So ये हमारे पास relationship आए हैं. So going to the dot and cross product, we know that if a vector is perpendicular to some plane, then we can write that vector is the cross multiple of the cross product of the directions of that plane. For example, here A star has to be equal or directly proportional, I should say, to what? Y plane and Z plane. So what is the primitive vector along y-axis? That is B, and along z-axis, that is C. So A star is proportional to B cross C. Okay. Similarly, talking about the dot product, we know that I dot I is 1. So if we say A dot A star, it should be equal to 1. But in our case, because we have marked this point on this perpendicular at a length multiple of 2 pi, so A vector dot A star vector should be equal to 2 pi. So we have got two relationship for A star vector, and similarly we will get B dot B star equals to 2 pi, and B star will be proportional to, what will be B star proportional to? B is perpendicular to Z and X plane, so it will be C vector cross A vector, and our C star will be perpendicular to A cross B vector. So I hope you all have got it what I'm trying to say here. So let's proceed from here. Removing the sign of proportionality, we can write it as A star equals to some proportionality constant A, B cross C. I'm solving only for A star, and then we will extend our relation for the B star and C star. So A star is equals to A, B cross C. Also I'm having relationship A dot A star is equals to 2 pi. So let's put in that, because now we have to calculate the expression for this A. So A dot, at the place of this A star I'm putting this value, which is A B cross C, and this is equals to 2 pi. So this A is a scalar, so we can take it out of the dot product, equals to 2 pi. That means we have gotten the value of A equals to 2 pi divided by A dot B cross C, right? Putting again in the expression of A star, the value of A, we got that A star is equals to 2 pi B cross C divided by A dot B cross C. So this is my expression for A star. Similarly, we will get the expression for B star and C star, and that we can easily write from here. No need to derive it again. So our B star will be, denominator will be same because the value of A will come same for everything. So denominator will be same, that is A dot B cross C. But in the numerator, we know that B star has to be in the Y direction, Y oriented. So this will be cross multiplication of C cross A. Similarly, the C star will be 2 pi A cross B divided by A dot B cross C. So in this way, we have found the relationship between reciprocal lattice vector and direct lattice vector. So these are the three expressions, and we will be using these expressions to find the reciprocal lattice vector of 3 cubic structure, which is simple cubic, face centered cubic and body centered cubic. So we'll be proceeding it. First of all, we'll be doing it for the simple cubic structure. So for the simple cubic structure, we know that the simple cubic structure would be drawn like this is a simple cube, and in the simple cubic structure we have atoms at the corners. And if I take this as my x-axis, this one as y, and this one as z. So this is my direct lattice. I'm writing DL here. And I have to find the same kind of points and its lattice vector in the reciprocal lattice. So let's first write the expression for A vector, B vector, and C vector. See, as we are considering the simple cubic, so here A, B and C will all be equal to, let's say, A. They all will be having equal values. So A vector is, this is my origin. Along x-axis I have to move A, and A vector will come out to be equal to A I cap. Similarly, B vector will come out to be A j cap, and C vector will come out to be A k cap. How? This is along x-axis, then we have taken this point along z-axis, and same vector, same distance A we have to move, and this is along the y-axis. So I have written the expression for A, B and C. Now I want to find out A star, B star and C star. And we have got the expression for A star, B star and C star. So let's write it. That we have calculated equals to 2 pi divided by A dot B cross C, B cross C. Everything is having vector. We are talking in terms of vector calculus. So it's very important to put the vector sign, don't forget. So first of all, let's calculate the denominator part, because the denominator part is same in all the expressions of A star, B star and C star. So to calculate this denominator, which we also call as volume of the unit cell. If you see, this is the exact expression for the volume of the unit cell. So B cross C, B vector is AJ cap and C vector is AK cap. So B cross C will be J cap cross K cap along with A square. 1A from J cap from B vector and 1A from C vector. Also we are having the dot product with this A vector, which is A I cap. Now just refreshing your knowledge from the vector calculus, J cross K is actually I. So A I cap dot, this will give me again I cap, and we are having A square as a multiple. Now the dot product is between I cap dot I cap, which is equals to 1. So the result of the volume we have got is A cube. So A cube is the denominator of each of the three expressions. Now let's talk about the numerator. As A star is equals to 2 pi divided by the volume that we have already calculated to be equals to A cube, and the numerator will be this B cross C here, and B cross C came out to be equal to A square I cap. So this will be A square I cap. So finally we have got the expression for A star, which is equals to 2 pi by A I cap, of course, because we are talking about A star, which is along the x-axis. Similarly, you will get the expression for B star. No need to calculate again. It will be 2 pi by A B cap, J cap, and C star will be 2 pi by A K cap. So these are the expression of reciprocal lattice vectors in terms of direct lattice constant, which is A. So I hope the point is clear to all. Thank you so much. That's it for today.